Good morning, everyone. I am Shish Kumar. Today, I will be presented a research paper titled "Machine Learning and Its Applications." This paper explores the organs, types, principles, and practical uses of machine learning in our daily lives. Let's dive into why this has become so crucial in today's technology-driven world. Introduction and need for machine learning. Machine learning is a subfield of artificial intelligence that allows systems to learn and improve from experience without explicit programming. Its growing use in speech recognition, fraud detection, and autonomous systems. It show it shows its transformative potential. There are several reasons why machine learning is important. When human expertise is unavailable, like navigating mass, when tasks are too complex to explain, like speech recognition, when problems change dynamically, like temperature control, and when problem size is too large, like ranking web content. Types and basic principles of machine learning. There are four major types of machine learning. They are supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning. Supervised learning, where algorithms learn from labeled data. Unsupervised learning, where algorithms find hidden patterns in unlabeled data. Reinfor- Reinforcement learning, where an agent learns to take actions for maximum rewards. Semi-supervised learning, which combines both labeled and unlabeled data. The basic principles is simple. Feed data into an algorithm, adjust its internal parameters during training, and improve its accuracy over time. Applications of machine learning in daily lives. Machine learning is deeply embedded in our daily lives. Some key examples: product recommendations. E-commerce platforms like Amazon use ML to suggest products. Face recognition used in social media to tag friends automatically. Speech recognition devices like Alexa and Siri interpret our voice comments using ML. Traffic suggestions. Google Maps predicts the best routes using traffic data. Dynamic pricing. Apps like apps like Uber adjust prices in real time based on demand. Survey results on awareness and use of machine learning. To understand public awareness of ML, a survey was conducted. Here are the results. 100% of respondents had heard about machine learning. 75% understood its applications like product recommendations and spam filtering. Another 75% felt in made their lives easier, showing a clear perceived value. Conclusions on machine learning. To conclude, machine learning algorithms are capable of learning from data automatically. It is a crucial subset of AI, helping machines behave more like humans. Businesses can benefit immensely if they choose the right ML tools for their needs. Summary and futures. As data as data grows exponentially, it's clear that manually processing won't suffice. Machine learning provides the automations we need to keep up. Its applications are now integral to services we use every day, and with ongoing research, the scope of power of ML we will only grow in the future. Acknowledgement and references. I would like to express my gratitude to my professors, teachers, and the head of the department for their continuous support. The reference listed here helped shape this research and presentations. Next, coming to coding part, installing and importing libraries. We start by installing and importing essential Python libraries like Pandas, NumPy, Seaborn for visualization, scikit-learn for model building, and JobLeap for saving the trained model. Loading the dataset. Next we load the dataset. In this example, we are using a CSV file named dataset.csv. We load it into a pandas data frame and take a quick look at the data using .ed and inform data exploration. Data exploration. We explore the shape, summary, statistics, and missing values. This step helps us to understand the data structure and spot any anomalies or pre-processing needs. Visualizing the target variables. We use Seaborn to visualize the class distribution of our target variable. This helps identify if our data is balanced or skewed, which is important for model performance. Pre-processing. We encode categorical variables using one art encoding and separate the features from the target column. We also perform a train test split to evaluate the model on unseen data. Future scaling. Scaling is a critical step, especially for algorithms sensitive to future magnitude. Here we use standard scalar to normalize the input futures. Input futures. Model training. We train a random forest classifier, a powerful and ensemble method that combines multiple decision trees. It's robust, handles high dimensional data well, and is relatively easy to interpret. Model evolution. After training, we predict on the test set and evaluate performance using accuracy, confusion matrix, and a classifications report. This matrix gives us insight into how well our model is doing. future importance. Random forest also gives us future importance scores. This tells us which future were most influential in making predictions. It's great for understanding the model and possibly reducing dimensionality. Saving the model. Finally, we save the trained model using Joblib. This allows us to load and use the model later for making predictions on new data without retraining. Finally, conclusion. This workflow represents a standard supervised ML pipeline. It can be easily adapted to different datasets and extended to include hyperparameter tuning, cross validations, or even deep learning models. Thank you.